Hello, this is Amos the Math Guy. I believe math is beautiful, and I would love to show you that through this series as we go through Journey Through Genius and Tools for Mastering Mathematics. Math is gettable and beautiful. Join me on this journey as I show you how. Enjoy the video. In this video, we're going to introduce Journey Through Genius from the beginning, and I'm going to explain the history of math in three major segments. We have ancient history, we have the Middle Ages, and then we have modern history. Modern history will start from the printing press. So we're talking about 1450 to 1500 and beyond. And that's where a lot of the mathematical theorems that you will see in this book will come from. But we will start from the very beginning of mathematics in the Journey Through Genius book. So there are three major resources here. We have The World of Mathematics by John Tyner, who has also written The World of Physics, The World of Chemistry, and The World of Biology. There's Journey Through Genius by Dr. William Dunham, and then The History of Mathematics, Burton's History of Mathematics, David Burton. So we have three math textbooks, or three math books, I should say, that will guide our discussion on the history of mathematics. We're going to start from the preface of Journey Through Genius. In his autobiography, Bertrand Russell recalled the crisis of his youth. There was a footpath leading across fields to New Southgate, and I used to go there alone to watch the sunset and contemplate suicide. I did not, however, commit suicide because I wished to learn more of mathematics. Now, that is a very sad situation going on there, and I want to encourage you, if you are struggling with any depression or mental health, that you please reach out to a professional. But this is very interesting for Dr. Bertrand Russell to share about his take on life. He wanted to learn more math. He was pretty serious about math. Now, this Bertrand Russell was involved in England. He was a logician, and very famous, a debate happened with Bertrand Russell, and part of his writings involved philosophy. G.H. Hardy, in the book The Man Who Knew Infinity, you hear the name Bertrand Russell mentioned. So Bertrand Russell is an interesting figure, important figure in logic in the history of math and science. Admittedly, few people find such absolute salvation in mathematics, but many appreciate its power and, more critically, its beauty. This book is designed for those who would like to probe a bit more deeply into the long and glorious history of mathematics. For disciplines as diverse as literature, music, and art, there's a tradition of examining masterpieces, the great novels, the great symphonies, the great paintings, as the fittest and most illuminating objects of study. Books are written and courses are taught on precisely these topics in order to acquaint us with some of the creative milestones of the discipline and with the men and women who produced them. The present book offers an analogous approach to mathematics, where the creative unit is not the novel or symphony, but the theorem. Consequently, this is not a typical math book in that it does not provide a step-by-step development of some branch of the subject, nor does it stress the applicability of mathematics in determining planetary orbits, in understanding computers, or for that matter, in balancing your checkbook. Mathematics, of course, has been spectacularly successful in such applied undertakings, but it was not its worldly utility that led Euclid or Archimedes or Georg Cantor to devote so much of their energy and genius to mathematics. These individuals did not feel compelled to justify their work with utilitarian applications any more than Shakespeare had to apologize for writing love sonnets instead of cookbooks, or Van Gogh had to apologize for painting canvases instead of billboards. In this book, I shall explore a handful of the most important proofs and the most ingenious logical arguments from the history of mathematics, with emphasis on why the theorems were significant and how the mathematician resolved once and for all the pressing logical issue. Each chapter of Journey Through Genius has three primary components. The first is its historical emphasis, the great theorems. On the pages ahead span more than 2,300 years of human history. Before discussing a particular result, I shall set the scene by describing the state of mathematics and perhaps the state of the world generally prior to the theorem. Like everything else, mathematics is created within the context of history, and it is of interest to place Cardano's solution of the cubic of 2 years after the publication of Copernicus' heliocentric theory and 2 years before the death of England's Henry VIII, or to emphasize the impact of the Restoration upon Cambridge University when a young scholar named Isaac Newton entered it in 1661. The second component is the biographical. Mathematics is a product of real flesh and blood human beings whose lives may reflect the inspirational, the tragic, or the bizarre. The theorems contained here represent the work of a number of individuals, ranging from the gregarious Leonhard Euler, which you can see his name on my shirt here, to the pugnacious Joan Bernoulli, to that most worldly of Renaissance characters, Gerolamo Cardano. Understanding something of the lives of these diverse individuals can only enhance an appreciation of their work. The final component and the primary focus of the book is the creativity evident in these mathematical masterpieces. Just as one could not hope to understand a great novel without reading it, or to appreciate a great painting without seeing it, so one cannot really come to grips with a great mathematical theorem without a careful step-by-step look at the proof. To acquire such an understanding requires a good bit of concentration and effort. And the chapters to follow are meant to serve as a guide in that undertaking. Now, part of what we're going to do in this course that is pretty cool is I'm actually going to go on the board and show you some math. And that's why I have a board right here. Part of it has a reflection, so we have to block that off. And then I'll be using the other part where I show you the work. So stay tuned for that. And by the way, if you want to support the work that I'm doing here, you can sign up for the courses that I have available on my website. You can also use the link in the donate link in the description if you would like to donate to the project, or email amosthemathguy@gmail.com, amosthemathguy@gmail.com. I teach math and math history, science and science history. I'm a medical physicist by training, but my goal is to raise the next generation of mathematicians, scientists, and thinkers who also know the history and philosophy of science, logic, and theology. So that's part of my goal in this quest, and thank you for joining me in this. So I will read a little more from the preface, and then we will pick it up from there in talking about ancient mathematics. We've already done a video on Isaac Newton and some other people, the French mathematicians. We're going to talk about Euclid and Pythagoras and some of these guys, and we'll work our way through the history of mathematics. Thank you again for watching this. Please feel free to subscribe and share this video with others as well. I hope to add some insight as we go through the history to inspire you to love math and love just mathematical reasoning. The final component and the primary focus of the book, as we said, has to serve, provides this opportunity for people to understand the theorems, right, themselves. And so the chapters that follow will provide that. That's the last component. There is a remarkable permanence about these mathematical landmarks. In other disciplines, the fads of today become the forgotten discards of tomorrow. A little over a century ago, Sir Walter Scott was among the most esteemed writers in English literature. Today, he is regarded considerably less enthusiastically. In the 20th century, superstars come and go with breathtaking speed, and ideas that seem destined to change the world often end up on the intellectual scrap heap. Mathematics, to be sure, is also subject to changes of taste, but a theorem correctly proved within the severe constraints of logic is a theorem forever. Euclid's proof of the Pythagoras theorem from 300 BC has lost none of its beauty of validity with the passage of time. By contrast, the astronomical theories of medical practices of Alexandrian Greece have long since become archaic, slightly amusing examples of primitive science. The 19th century mathematician Hermann Hankel said it best: in most sciences, one generation tears down what another has built, and what one has established, another undoes. In mathematics alone, each generation adds a new story to the old structure. In this sense, as we examine the timeless mathematics of great mathematicians, we come to understand Oliver Heaviside's wonderful apt observation: logic can be patient, for it is eternal. A number of factors have gone into the selection of these theorems to represent the best of mathematics. As noted, my chief consideration was to find arguments that were primarily or particularly insightful or ingenious. This, of course, introduces an element of personal taste. I hope that you have enjoyed this preface discussion. We'll be going through Journey Through Genius, and there'll be a playlist. Subscribe for more videos on this. We're going to do the theorems, as I said, some of them on the board. I will also have a video series that goes over my book, Tools for Mastering Mathematics, and my curriculum, Counting to Calculus. Thank you again for watching. Have a blessed day.